Dear students, welcome to the today lectures on transform and boundary value problem, Unit 1 PDE. So in last class, we seen about case 1 number of arbitrary constants less than or equal to independent variable case problems. But many students are asking why this one is important. What is that difference between the case 1 and other cases? So the basic idea about this, I explaining like using last class problem. For example, if I'm taking z equal to ax plus by, this equation, we have to, using the elimination technique, we have to remove a and b constants using what is that special standard notation. We have to apply a equal to b, b equal to a, q equal to b. So how to get this one? First we have to differentiate the equation, partially differentiate the equation with respect to x, and to partially differentiate the equation with respect to y. So what will happen if you are differentiating with respect to x in equation 1? Dou z by dou x equal to a. Here dou z by dou y equal to b. So this one become p equal to a. So this equation become q equal to p. So finally, if you are applying p equal to a, q equal to b in equation 1, so you can form the PDE. What is a PDE? P x plus qy. So this is the first case. So in this first case, what is the dependent variable? The dependent variable is z. How many independent variable? X and y. What are the arbitrary constants? A and b. So x and y, two independent variable, arbitrary constant a and b. So two independent variable there, two arbitrary constant there. So you are using two equations. What are the equation? Dou z by dou x. This one. Dou z by dou x equal to a, and then dou z by dou y equal to b. So two arbitrary constants, two independent variable. So you obtain only two equations. This is the case 1 normally. So you are framing, you are eliminating the AB constant, so you can form the PDE. But why this one is important means, for example, if I'm taking the example z equal to ax plus by plus c. So in this case, how many dependent variable? Dependent variable usually is that independent variable x and y, arbitrary constants a, b, c. So two independent variable, three arbitrary constants. But in case 1, what we are using? Dou z by dou x equal to a, dou z by dou y equal to b. So how to eliminate? How to eliminate the third constant c? So this is the question. So in this equation, so here from in this equation, in case 1, we can't form the PDE. So in for this equation, in case 1 method, we cannot form the PDE equation. So therefore, we have to move the next case. And the importance of this model, for every independent variable, we can obtain one independent partial derivative. Therefore, if there are two independent variables, we can eliminate at most two arbitrary constants. If the number of arbitrary constants is greater than the number of independent variables, all the constant cannot be eliminated. Which means for every independent variable, we can obtain one independent partial derivative. For every independent variable, for example, dou z by dou x, dou z by dou y. But when that arbitrary constants greater than the number of independent variables. So arbitrary constants So when the arbitrary constants are greater than the number of independent variable, we have to move the next case. Case 2. So number of arbitrary constants greater than number of independent variable. So here, for example, if you are taking the example of x square by a square plus y square by b square plus z square by c square. So this is one example of case 2 when the arbitrary constants greater than the number of independent variable. So here independent variable x and y, but arbitrary constants a, b, c. So here, so the PDE of order greater than 1. So we have to use the standard PDE notations like PQRST form. So in this PQRST form, dou z by dou x equal to P. What are the standard basic notations? Dou z by dou x equal to A. Dou z by dou y equal to, dou z by dou x, dou z by dou x equal to P. Dou z by dou y equal to Q. Dou z by dou square z by dou x square equal to R. Dou square z by dou y square equal to T. And last one, dou square z by dou x dou y. Or you have to write dou square z by dou y dou x equal to equal to S. Equal to S. So these are the basic standard notation we are using in forming the PDE. Then the number of arbitrary constants greater than number of independent variable. So in the problem, dou z by dou in the problem x square by a square plus y square by b square plus z square by c square equal to 1. So in this equation, first we are differentiating partially differentiate with respect to x. So what we get, so with respect to x, the first term have x, so 2x by a square plus second term does not have any x, so differentiation 0. Third term also does not have x, no, because z is a function of x and y. So insert z both x and y there. So what is the differentiation? So normal z square differentiation is 2z this is partial, so dou z by dou x with respect to x. So we have to multiply with dou z by dou x term equal to 1 differentiation 0. So now 2 will cancel, x by a square plus z by c square dou z by dou x equal to 0. Mark this is equation 1. So in this equation 1, we have to write in the term of x by a square plus z by c square. So the dou z by dou x equation will become x by a square, z by c square. So this one is nothing but p equal to 0. So I marked this equation is 2. So now partially differentiate equation 2 with respect to y. So what we get? So first term does not have y, so therefore directly 0. second term z there. So z is a function of f of x comma y. So here p means dou z by dou x. So if I am considering this one, so here one z there. So p is nothing but dou z by dou x. So here z, here z. So 1 by c square. I am considering this one is a constant. So here z there, here dou z there. So you have to apply uv method. U v dash plus v u dash. So z that consider as constant. So what is the dou z by dou x differentiation? Dou square z by dou x. This is with respect to y. So dou y plus I am considering dou z by dou x constant. What is that concept? U v dash plus v u dash. What is the differentiation of z? Dou z by dou y equal to 0. See? So what we did? Take dou z by dou x. So this is, you have to apply uv method. So u v dash plus v u dash with respect to y everything. So check here, check clearly. This is considered u, this is considered v. So u v dash with respect to y plus v u dash with respect to y. So now apply here. Now simplify. Z dou square z dou x dou y c square. I'm writing clearly in next slide. So what is the differentiation? 1 by c square of z dou square z by dou x dou y plus dou z by dou x dou z by dou y equal to 0. So now multiply with c square inside. 1 by c square dou z by dou x dou z by dou y. So as per the standard notation, what we get? So both sides c square there. So c square you have to eliminate because both are constant. So you will get dou square z dou x dou y plus dou z by dou x dou z by dou y equal to 0. So now apply the standard notations here. Apply the notations. Z, this one S plus this one P Q equal to 0. So which is a required PDE. So what are the notation? Dou square Z by dou X dou Y represents S. Represents S. So dou Z by dou X, this is P. Dou Z by dou Y, this is Q equal to 0. So this is the required PD. So similarly, we have to solve the many problems in case 2. In case 2, so the proper explanation means when the number of arbitrary constants is greater than the number of independent variables, the first order partial derivatives are not sufficient to eliminate all the constants. Therefore, we differentiate again to obtain additional equations involving second order derivatives. For convenience, we denote the first order derivatives by PQ and the second order derivatives by RS and T. This process usually leads to a second order or higher order partial differential equation. So we have to understand both cases using these examples. So next, one more problem. So find the PDE of all planes through the origin. So this one I'm giving you for homework. The the hint is the general equation to a plane is ax plus by plus cz plus d equal to 0. So find this one is case 1 or case 2. So find and then solve this one for homework problem. Thank you.